All right. How's everybody doing? Hopefully you can hear me. If you cannot hear me, then, or if you can hear me, put something in the chat so that way I know you can hear me. If I don't see anything, then I'll know something is wrong. Awesome. Okay, good. My internet is really bad, and my broadband is really bad, and it decided to go out 20 minutes ago, which is not unusual. So I had to break out my Starlink, and I had to get like the $50 ring plan. So I guess I'll be going camping or something soon, so that way I can use it the rest of that day later on. But I don't know. The streaming might take up all my data, so I got to kind of keep an eye on it. So, all right. Well, thank you everybody for coming and tuning in to me basically geeking out and showing you some of the things that I have been learning and working on over the past year, year and a half almost now. I started a cybersecurity training program about back in February of last year, and I didn't know anything about computers. So the fact that I kind of came this far and kind of know a little bit about what's going on inside of a computer, what's going on inside of a network, I have wanted to try and tackle some more ambitious projects. And so I'm going to try and document that as best I can because I think it's good to get myself out there and put myself put a little bit of pressure on myself, because I'm about to do a project here that probably is pretty well outside of my comfort zone, in terms of Python and in terms of my knowledge of networks and stuff like that. But I think that at the very least, I'm going to learn something. So today what we're going to do is, my whole idea is I want to try to understand the internet from the very basics, like the very basic protocols that are used on the internet, try to break them down in a way that they can be coded or scripted or however you want to call it. So we want to see what's going on inside of these packets in between computers and how they're communicating with each other, because I think the fact that I can send packets of information across the globe and reach a server in Europe or China or whatever, and it comes back to my computer, and the amount of data that is transferred over the wire, with all the other traffic of the world as well, is pretty astonishing. And so the internet has really fascinated me lately, and I think it's a great place to. I think everybody should kind of have a basic understanding of how the internet works. Now, that being said, what I'm doing today is pretty complicated, and for example, I can't assume that you know stuff about Python. Python is a whole way too big of a project for me to explain to you before I start coding this server. But I am not going to assume that you know much about networking. And so, as I code some of the Python stuff, then I'll try to explain best I can. Not sure what you mean by that, Q, but I'm going to try to explain a little bit as best I can of what's happening in the code to help people understand a little bit better about what the, yeah, exactly. It's hello world. We'll send hello world across the internet. We actually will here in just a second. Okay. All right. So first thing I want to do is, before we actually even get to Python, I want to explain a little bit about networks in general and a little bit about, we're going to code a DHCP server. So what does that mean? And why did I choose it? So in order for a computer to communicate with another computer, it has to be able to find that computer. And I'm going to dive even a little bit deeper into how a computer communicates, because a computer might also have to communicate with itself. And like one of the first page of networking, the first page of Network Plus, in my opinion, should have been sockets. And what is a socket? And this is going to be very poor artistic expression here, but not even sure how this program works anymore. Okay. There's a text box. So this is your CPU. Okay. And this we'll just call memory. That nope. Oh no. Yeah, I did not prepare to use Paint today, so well, you can read that. I want to move along, but inside of memory, you have different applications running. And one of those applications is your operating system. Okay? That's how you move it right there. And then you might have something like Word running. And you might have something like Excel running. And your CPU needs to be shared between all of these different programs. Okay? And that's the role of the operating system. The CPU will always read from the operating system first, and there's something in the operating system called a scheduler. And the scheduler decides how, when each application is going to use computing resources, basically the CPU. And this is a very like dumbed down version of how the CPU works and how the operating system works. But your CPU, in theory, can only run one instruction at a time of a program. And so the scheduler says, okay, we can have Word run these instructions, and then we'll schedule Excel to run these instructions, and then we'll go back to Word, and we'll go back to another application, and then we'll give some more time to the operating system to tell us a little bit more about what to do and this kind of stuff. When this happens, though, since you can only run one instruction at a time, how do applications communicate with each other, right? So like, let's say you want to embed an Excel spreadsheet into your Word document. Like, that's a feature. How is it that your Excel can be talking to your Word at the same time? Well, inside of the memory space of the operating system, there are these little mailboxes. And they have a number associated with them. And they're called ports. And if you know anything about networks, you'll probably know about like port 80, port 443, what have you. This is just a little memory space in the memory of the operating system that your application will send data from its memory space to the port. So Word will send data, not to port 80, but some other port in memory. And then Excel will read from that port, right? They will read the data inside of that port and bring it into its memory space. And this is called inter-process communication, or IPC. But this is also the foundation of networking, because all networking is an application in my memory space talking to the application in the memory space of another computer, and it uses my operating system or some port in my operating system to be able to communicate with a computer somewhere else. But so we can use our ports for that, sure. But we cannot just use ports, because your computer is probably using the same ports as my computer for applications to talk to each other. So in order for us to find another computer, we have to be able to address it. And this is called an IP address. And usually you'll find an IP address that's an IP address and a port coupled together with it like this, with a colon. Okay. So it can say, I want you to find the computer with this IP address, and I want you to put it into this port. And you couple them together like that in the code, okay? Now, this is called a socket. Okay. And we're going to create sockets in Python. And it's what happens in Python, though. The sockets you create in Python are very, what we might call, high level, where we have taken the functions and we've taken the components that create a socket inside of the computer, and we've abstracted them to such a high level that you basically don't understand what's going on. I mean, really. Which is good for programmers, because we don't want to have to recreate the wheel every time we want to send packets over the network. But it's bad for like learning purposes. Like I don't really understand how sockets work. I don't really understand like the system call that gets involved in order for you to open up that passage. But basically how it happens is there is a that you access that part of memory in your operating system with something called a file descriptor, or actually it's probably just a pointer, but it points to that location in memory. And that's way beyond the scope of this, but that's what a socket does, and that's like the crucial thing to understand when networking. Okay. So, what does a DHCP server do? So we know that we need IP addresses in order to communicate with another computer. So what I have here are just 3 examples. If you really wanted to, hook up just 2 computers connected to each other, then you can, and you can communicate. So I have here a web server. It has these files inside of the server for us to access. Basically, if you don't know how web server works or how your browser works, like when you click on a website, then or you enter a website into your search bar, it sends a packet out to a web server, and it gives you something called an HTML file, and it usually is called index.html, and that contains all the code for the web page that you're about to look at. Okay. I want to check something real quick. I want to check my Starlink data just to make sure. Yeah, it's definitely using some data, but we'll keep going. We'll keep going. So what we've had to do here, in order to get these two computers to communicate with each other, we have to give them both IP addresses. But when a computer starts up, it doesn't have an IP address. You don't really put the IP address like on the disk, for example, like in persistent memory. You wouldn't do that. It exists in the memory, in your RAM, in that little space in your operating system, right? So each time you turn your computer off, you lose your IP address. So you can't just have your computer have the same IP address all the time. What you have to do is you have to actually program your network card to have an IP address. And this is what an IP address looks like here. And this is an identity that needs to be unique on your network. So I've literally actually typed this in. On my PC here, I have also typed in a static IP address, a manual IP address. That's what it's called. Static IP means you've typed it in yourself and it doesn't change. Okay. Now, there's a packet here. I'm not sure what this packet is, what it does. Oh, it's an ARP packet. Okay, we won't discuss ARP today. Go to access. If I want to go to access my browser and my web server, I can go to 192.168.1.20. Is that what it is? And look, so here is this packet here. This is a little envelope. If it's going to work, it's not going to work. This is a little envelope of information encoded into bits, like little ones and zeros that are about to get sent out online. And look, right here, these are ports. So port 80 right here, that's the port that web pages run on, right? So it's going to send a packet to port 80, and the server, it's got this little operating system, a little mailbox in the operating system. It's going to put that information. This packet move across the network. Oh, let me try that again. Okay. Well, that didn't seem to work. Uh-oh, y'all. Did I get the IP address right? Hold on. I didn't get the IP address right. Okay, sorry, my bad. .40. Okay. So we're going to watch this is a request to get the web address, or to get the IP address of the, to get the web page. I guess that one is. Now that this packet is in the possession of the server, the file and send it back. And if we open up, I'm going to put this in real time, but basically what you'll see is we get a web page. Okay, and in this web page, you can access a small, you can access the different default web pages that this program lets you access. It's called Cisco Packet Tracer, if you want to play around with it. But that's how a web page works. That's how. Okay. So yes, you can hook up to computers directly, and they can communicate with each other using IP. But that causes a problem, because you don't want to have a network of 200 computers and that you go in and manually configure each of their IP addresses. Like, that's ridiculous. And then what happens if you have duplicate IP addresses? Then your computer will mistake the computer that you want to access for another one. So, like in this scenario here, we have 4 computers hooked up to each other. We can and have configured all of these to have IP addresses. So any of these can, in theory, access that server. Let me just figure out what the IP of this is again. 40. Okay. Do a ping. A ping is just data sent to the server, and then it sends a response back so that way you know you can reach the server. And we're getting a reply. So any of these computers can connect. But if we want to add a new computer to the network, we would then have to know the IP addresses of all the other computers. We would need to make sure that we didn't assign it to the IP of another computer. And we would, we cannot keep up with that. We cannot keep up with that. And so what we need is some sort of computer on our network that will serve out IP addresses automatically and keep up with all the IP addresses that are already on the network. So that way you don't ever have a screw up. Because if you think about it, right now, all of your phones, if they're on cellular data, they're all kind of using the same DHCP server. Inside of your modem or your router or anything where the internet comes in, they're all using it's got a little tiny DHCP server inside of it. And you don't even know that whenever you turn on your computer, it sends out a request to that router and gives you a reply about what your IP address is going to be. And that's the problem that we want to solve today. So if I turned off all of these devices, and then turn them back on, before I do that, I'm going to go back to simulation. I'm going to turn this back on. That's not the packet we want. It'll come. It'll come. But you see how these computers are connecting automatically? And I don't think that this program actually does it. But like in theory, that would go away. I don't think this program does it. Or I could turn it to DHCP here. It's this orange dot here means it's not connected. It cannot access the network because it has no way to know what other computers' addresses are. And so this is the problem that we need to solve. And this is the problem that folks back in like the 80s and 90s, whenever the internet was first starting to be developed and they were realizing like, oh my gosh, we have a ton of devices that are going to need to be added to this network, because the internet was just a sort of project for the Pentagon to help them communicate better. Back in those days, like, it probably wasn't that big a deal to keep up with all of the network addresses and all the computers and stuff like that. But as the internet began to grow, they needed to solve this problem. and they needed to solve a bunch of other problems about networking. And so they created a series of documents, and those documents are called requests for comments. How we're going to figure out how the DHCP works and how we're going to code our DHCP server. I'll be right back. These documents basically tell us how the internet works, and there's a lot of them. But this one was written in 1997. This is actually the updated version. There was another kind of DHCP before that, but it got updated by this one. But before that, there was another protocol called Bootstrap Protocol. And this is an interesting protocol. It works sort of like a DHCP server in the sense that there's actually a server that distributes IP addresses, but the system administrator, the person who administrates the network, has to keep up with all the new devices being added and add their computer based off of what's called a MAC address. They have to add each computer as they're added to the network, and this is just too cumbersome. This is just too cumbersome. So they decided, well, what we need to do is be able to dynamically assign IP addresses, meaning that if a user connects, if a computer connects, it can get an IP address without anybody having to configure it. Okay, so I am not going to be able to like meet all the specifications of this document. Okay, and so we might make some compromises, but basically, for me to succeed in doing this project, I think if a device, it can be any device, it can be my iPhone, it can be my computer. Remind me not to try and use my computer to test this with, because I will lose the stream. But it can be any device on my network. If it can release its IP address and get a new IP address without me having to configure it, then I've succeeded. Any device. Okay? If we look at section 1, part 3, after obtaining parameters via DHCP, a DHCP client should be able to exchange packets with any other host on the internet. And whenever it says on the internet, it can mean that just means a network of networks. It doesn't necessarily mean the World Wide Web. But in theory, yes, I would be able to communicate with any device in the World Wide Web. So if I can do this, then I've succeeded in my project. Now, there are some specifications that I would like to incorporate, but I might not be able to, simply because of time resources. The DHCP server has to be able to not only do dynamic allocation, which is what we've just been talking about. Basically, if a computer connects, it gets an IP address automatically. But it also has to be able to implement automatic allocation, which means that if a new device connects, it receives an IP address, but it keeps that IP address forever. In dynamic allocation, which is what we've been talking, it's a lease time address until the lease time is over, and back to the DHCP pool, which is the pool of addresses that devices are allowed to pull from. It has to give that back up and then receive a new one. And usually it's the same one, but not always. But in automatic allocation, it is. It always is the same. It can also needs to be able to do manual allocation, which means that in the server, we manually allocate a device of an IP address. And so that way, and whenever it connects to the network, it always gets that IP address, and it never changes. And these two are kind of similar, but the only thing about automatic allocation that's different from manual allocation is that you don't have to configure the IP address on your device. It gets one from the DHCP server. You don't have to configure anything in the DHCP server either, but it always gets it keeps that IP address forever. Manual allocation, though, you do have to actually either go into the DHCP server and be able to allocate that address to that device every time. We may not touch these, but it would be nice to add. Okay. How do we know whether or not a IP address has been assigned to a device? That is done through binding. Binding is a collection of configuration parameters, including at least an IP address associated with or bound to a DHCP client. Bindings are managed by the DHCP server. Okay, so what this means is that every device has something called a MAC address, and it's a unique code on your device, hardwired into your device. So it's a little bit like an IP address, except IP addresses can change. Your MAC address never changes. If we can have a table inside of our DHCP server that assigns an IP address to a MAC address, then we can know which which IP addresses are being used and which clients they're being used by. Okay. Some more things that I'm going to try. Well, I have to pursue in order for this to be a proper DHCP server. Clients should require no manual configuration. Like I said, clients have to be able to connect to the network automatically if they've released their IP address, meaning it could have been restarted or we could have lost internet connection or something like that. It has to be able to manually it has to be able to automatically connect to the network. We'll get into how this works in just a second, I promise. But network manager should not have to enter any per client configuration parameters. So this means that like I shouldn't have to make exceptions for certain devices or something like that. It has to be any device. And then this is probably a feature I will not be able to touch. I will not be able to implement just for time purposes, because it would take a really long time for me to code something like this. A DHCP client must be prepared to receive multiple responses to a request for configuration parameters, including multiple overlapping DHCP servers to enhance reliability and increase performance. Like, I don't want to be, I'm going to turn off basically my DHCP server whenever I test this for real. So that way I'm not competing with it. Just that way I know how it works, that it works. Also, I probably will not I probably will not meet the qualification to for this. DHCP server should not require a server on each subnet. A subnet is basically like one of these, and then you have something called a router that comes out to here, and then you can connect two networks together. I'm only going to do it for one network, and like I said, this is not going to be a real DHCP server. I'm really just concerned about like how dynamic allocation works. Okay. I was going to say something else. I will probably remember it as we begin coding. Okay. Let's get into our coding machine here. Start. Why am I getting this black line? Oh. Okay, this is just a computer that I have in my house that I connect to over a remote desktop that I use to do some projects in. So if you're wondering, like, how's he using a different operating system on the same computer, technically I'm not. You can do that sometimes, but I'm not. This is actually a different computer. So let's see what directory. Let's go into Python projects. And you can see I've kind of already been playing around with this. I just wanted to make sure that I got somewhat far enough to fill up good content for the stream, but I didn't really get too far. So we'll definitely get to a point quickly where I am in new territory. So I'm going to call this I'm going to create a virtual environment for my Python code. And again, like, I'm sorry if you don't understand the nomenclature of Python and all this kind of stuff. I will explain to you, like, the important things. Those of you who do know Python, I will narrate the rest of it as well. Just that way you can keep up or follow along if you want. I probably will try and post the code on my GitHub as well if you want to look at that in my repository. Okay, so I'm going to create a new virtual environment. I'm going to call it just a DHCP server or project. And I'm not using any outside packages or modules, I don't think. Well, I'm going to use Scapy, but I think that it's probably installed globally on my computer. So I don't think that we really need to create a virtual environment. But I'm going to anyway, just because it's a good practice. I'm going to cd to DHCP project. Then I'm going to do activate. Source activate. Is that how it's done? Source bin activate. Okay, good. We have a DHCP project virtual environment. We will open up VS Code, which is what I'm going to use to do this project. Open folder. Yes, address the authors. And we're going to make a new file, call it server.py. And good. Okay, we're in our virtual environment. Okay. So the first thing we've talked about sockets. Python has a module called sockets. or socket or something like that. This is basically the module that contains most of your low-level networking functions and classes and variables, objects, what have you, with Python. Later on down the line, we're going to need Scapy, right? Maybe that's not how you import it. Well, I only need one tool really for today, and that's from Scapy. Okay, now it's not working. Let's try and reinstall Scapy and see. Is this gonna work? There it goes. And that package is import. Sorry, my bad. Import utils dot xdump. Is that how it's done? And this is just how it's going to be because I'm not great at Python, and that's why I'm doing this. I'm just going to be looking at a lot of documentation and trying to figure out how to do everything. Xdump. And I'm just doing a little bit of a look. Might be able to do it without Scapy, actually. Python. All right, we'll have to figure that out when we come to it in the code. Because this is Scapy probably will not be used in the final production code, but it's going to be used for debugging purposes. And then, okay, so let's just look at some of the RFC. Let's take a look at that. So that way we know where to start. So we've talked about ports a little bit, and what is really important for me now to figure out, because I want to create a socket, I need to figure out which port to put it on. So let's look at protocol summary. I bet that's where it would be. Go to 2. This is looking promising. And I know which ports they are on, but I just kind of want to see if I can find it in the documentation to show everybody. Okay. Probably in here somewhere. So in here somewhere, it tells you which port it's supposed to go on. The 2 ports are, it actually has 2 ports. Some protocols only have 1, but this one has 2, and it is 7 and 68. So these are the little mailboxes in our operating system that we need in order to pull data from. So we're going to create variables out of those. We're going to call this, I think it's, actually it would be good to know. Maybe I have it highlighted. the server port, we'll call this server port equals 67. And the client port equals 68. And now we need to bind our, or we need to create a socket, but we need an IP address. So, okay, so what IP address do we use? Like, if we're gonna be getting a packet from basically any device on the server, what do we use? Well, it's called a broadcast address. Or sorry, you use a broadcast address to talk to all of the to everybody on the server, and you can listen to any IP on the server by using the address 0.0.0.0. So if you bind a socket to this, then it will listen to any request. And what the clients do is they broadcast. They do a broadcast packet, which is they use the IP 255.255.255.255. It will broadcast. I can now listen to any packet that's broadcast on my network. And so this is what will enable us to get data from that client device. Okay, so we're going to create a socket, and that is done by doing socket.socket. And these are these have very specific reason that the parameters are this way, and it has a lot to do with C code, which I just won't get into right now because I do not have time. I don't really want this stream to last more than maybe an hour and a half. So I won't get into it, but it is kind of interesting. The parameters for this are AF inet. Sorry, you gotta call this socket module, socket class, excuse me, socket.af inet. Basically, this parameter tells the socket that it's an IPv4 address. I won't get into what that is right now, but you could always go Google it, but that will probably lead to more questions. In fact, I guarantee it. And then this will be a socket dot. There are two different types of protocols used on the internet mostly. There's you'll hear people describe it as a secure way, and you'll hear other people call it the efficient way. And the secure way is called TCP, and what it does is it basically every packet that's sent, it ensures that it reaches its destination by having the server then send back a packet saying hey, we got all your data. We're not going to use that one. DHCP does not use that protocol. According to the RFC, it uses UDP, which basically just throws packets out there towards the destination of your server. So in theory, your packet may never even reach your server, and if it doesn't, then you won't get your IP address, and your computer will have to send out another packet, and that's okay, because this is that stuff happens so quickly that you never notice. TCP is more for if you want to ensure that your packet has reached the other side, you have crucial data or something like that. Right now, you're using UDP to stream me, for example, because if you lose a packet, you probably won't even notice. But if you lose a packet of say banking or something like that, that's a really bad thing. So you want to use TCP, but we're going to use dgram. And this just tells us that we're using a UDP packet. Now we need to, now this will return, I'm not sure exactly how it works in C. I've never coded a socket in C, but I think basically it returns either a pointer or a file descriptor of some sort, where basically this bit of code right here, you need a variable to catch that in. So we're just going to call this maybe server, and then we'll call the other one. So because we have two ports that we have to work with, that means we have to have two sockets. So we'll call this client socket, and that will equal socket dot socket, and then we'll go, it'll be the same socket if socket dot sock dgram. Okay, good. And now we've created, see, here's the other tricky thing is like, you've created a socket, but that socket actually doesn't have what you might call a binding. The socket doesn't know which port it's listening on, doesn't know what address it's supposed to be listening to. So we are going to do, we're going to create a binding. And that is done with server socket dot bind. So that's a function that's used to bind them together, and you have to do double parentheses because it only takes one argument. And it is going to be address and server port. Nope, server port. Okay, good. And then we'll do the same with the client socket. Nope, dot bind. And that is a client port. Good. Sorry. So we've binded the address, or we've binded the socket with the address that just basically says, listen to any packet that is sent to you. It doesn't necessarily need to be for you, but if it's a, say, a broadcast address, then you can listen to it, and you should. Like when you have a web server and people try, and you access a web server across the internet, that server, I guarantee you, is listening on 0.0.0.0.0. Now, if you only want one computer to communicate with you, then you can use that computer's IP address. But in a production server, you really don't want that. In a server client architecture is what you would call that. Now, there are like host-to-host, client-to-client architectures where maybe, like Bitcoin is a perfect example of that, where maybe you don't want like a centralized server, and then you might be able to get away with using like individual IP addresses. But that's not how it works for this situation. And I'm not sure that that's how Bitcoin works. I just know that that's kind of an example. Okay, in order to listen to a connection, we need to create a loop. And I'm going to define a function. And I know this is not going to be like the cleanest code. I feel like somebody who's really talented in Python would have already created like a class called server or whatever that does all the functions for it. I'm going to do that eventually, but like right now I just want it to work. So main, oops, I just want main. We're defining a main function here. I'm going to do running equals true. Wow. Wow. Running. Sorry, my development computer is laggy. We're going to server socket. Socket. This function's a little bit different from what I usually mess with. I usually do TCP whenever I'm fiddling around with sockets. Is receive from. I think it's received from. We can look at the Python documentation for this. Receive from is a function in Python, so I don't know what that around. Yeah, from UDP. I'm just going to open up this right now because this might come in handy later. This is the Python official documentation. Receive. There will be parameters. It's going to be a buffer size. This basically just tells us like the size of in memory that we want to allocate towards receiving packets. That's going to be 24. And then we have this we need, that's going to return data, like, right? So we need to capture that in a variable. And we're going to call that variable just raw. So that's just raw data. Okay. So in theory, then, we should be able to get data from a computer trying to get an IP address. But what I want to do before we test, first off, it's going to ask me to do this to server socket dot get sock prompt. Python documentation. Python documentation is not really all that helpful. And I think this is one of those times. There's something going on at my door. Let me check it out over here. Okay. Comment that out and get the from it whenever it inevitably is an issue. And then I'll look at the error code and maybe that'll help me out a little bit. Okay. I also want to open up Wireshark so that way I can read packets. Okay. And I'm going to listen on port 67 or 68. And I mean, you'll probably see some data just from random devices on my network, but I'm going to just disconnect my iPhone and reconnect it and see what happens. Literally nothing. And that's because I'm connected to a different network. I'm connected to my Starlink, I bet. So I'm going to connect to my broadband. Well, yeah, look, right there. Good, good. Okay. So let's take a look at this packet capture. And I want to get into this next time more so than this time. But basically what is happening here is a process called DORA, which is since your computer doesn't know like what IP address your DHCP server is at, because it doesn't have an IP address and doesn't know what network it's on, it broadcasts a message. And that's why I'm able to get this packet, because it just sits at every device to say like, hey, are you the DHCP server? And so it asks my device, am I the DHCP server? And then I'm not, so I just drop the packet. And this is called Discover. What I think I would like to do today before the stream ends is to get a Discover packet. We'll talk a little bit more about DORA next time, but basically the DHCP server, and the DHCP server says, hey, are you interested in this IP address? Your device will say, yes, I am. Please send it to me. And then it'll send the configuration to you. If I can get a Discover packet to show up on my server, then I think that'll be good for tonight. To look at that a little bit. Can put Wireshark away. Time being. Let me run the server. If it will let me. There might be some permissions issues. Sudo Python 3. It's not going to work. It's not going to work because I did not call the main function, and I got my password wrong. So. I need to print. I'm just going to see. This is probably just going to be. I'm not sure if that's going to work. I don't know if you can print raw data, but find out. Call the function, and then let's run this again. I probably did not do this. I didn't save it, I don't think. You can do Control S to save a document in VS Code. Okay, got an error. Address already in use. Maybe I got this wrong. Maybe this is supposed to be 67. This is supposed to be 68. Server. Really? Oh, it's in use by Wireshark. Wireshark is listening on that port. Wireshark. Stop that. See if it'll listen. Okay, still no. Maybe this was right to begin with, though. That's what I'm curious about. Okay. Address already in use. I mean, I guess it's in use by my DHCP application on my computer already. Okay. I think that's what this is for. I think we need to do something with this function. Let's see. Okay. 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 Sock opt. We need to do socket.sol. Socket dot so reuse port, or maybe reuse address, because it's telling me that the address is already in use. Let's try each of them and see if this works. Control S to save. Okay, let's try this, and then we'll change it to reuse port maybe. Address already in use. What happens if I do this? I wonder if that's what it's mad at me about. I bet it is that. I bet that's what it's mad at me about. Really laggy over there. Yikes! Yo, come on. Oh, oh. Okay, hold on. Hold on. I'm gonna print this to the terminal so that way we know if it's running. Didn't save. It's okay. Server is running. Okay. Let's see if it reads a request from my iPhone here. Did not. So let's get Wireshark back out. And let's start capturing packets again. Okay, gotta reconnect. Okay, so we're getting packets from through wire. Port are we getting those on? Destination port. $67. Interesting. Okay. I just want to make sure that my servers can actually receive data. So let's do this client.py socket. Let's do s equals socket. So 255 dot. I think I know what's wrong. I think I know what's wrong. We need to open up some firewall rules probably, which is interesting to me that you have to do that because you would think that like DHCP is already a service running on this computer, so why would we have to open up the port? But let me just try and see if that works. So UFW allow, and it's probably going to ask me, I'm not exactly sure how the syntax for this goes, 192.168.0.0, or maybe X. Yeah, that's a good point. Oh, /24. Bad port. It's supposed to be X. Bad port. Okay. Messages. I tell you, listen, y'all. Like Google, all search engines are just terrible now. You can never find what you want. Okay, so we could do this. We could do 0.0.0.0. We could do this. I don't necessarily love that solution for right now. I guess technically we'd have. Let's just go ahead and do it that way. Bad port. What are you talking about? Maybe that needs to be 0. Y'all listen, this is gonna drive me insane. Okay, I'm going to move this over for now to the other screen because it might show incriminating data about my network. Let's see. See. was the terminal? I know that. Let's see. Do wow. Allow rule. Did it. I did it. Okay. UFW. Oh, 68. That's another good point. Need to be root. Okay. That was easy. Okay, let's run this again. Server is running. Okay. We're kind of coming to the end here, so I'm hoping this works. Okay, that did not work. Let me try one more thing, and then I'm gonna call it. Let's see. I want to try to change these out again. Because that was set to 67, and I opened up 68 in the firewall, which I think it's supposed to be 68 anyway. So I just kind of got my ports confused there for a second. Socket already in use. Address already in use. Okay. I did get that right. Maybe this is 68, this is 67, and then I need to open up UFW, allow 67. And I need to be root. Okay. All right, I'm going to try this one more time. If I can't get it, I'm going to go ahead and to being able to get discover packets. This, this server is working. I think it's my firewall that I'm having issues with mostly. So let's make sure I saved everything. Server is running. Disconnect from the Wi-Fi. And Hey, I got it. Look at that. Okay, that's great news. All right. So this is the form. So this packet, when it gets received from the server, it can look at this packet and say, okay, I know what device this is. I can send an offer of an IP address. So we'll talk a little bit more about DORA and the process in which these clients and servers go through in order to get the data to one another next time. But this is a great start, and this is authentic data from my iPhone that I actually picked up through my server here. So we're off to a good start. All right, for those of you who are still sticking around, I really hope that you subscribe next time.